For everything in nature relies upon something else. Nothing can exist on its own. And plants are a vital part of this chain that we're talking about. And actually, plants are flipping amazing. They really are. It's hard to imagine that plants can be interesting. You look at a plant and it ain't doing anything. It's not doing anything exciting, is it? It just sits there, you know. But they are incredibly beautiful to the human eye. And many of us find them, this is a dog rose that we see on the screen in front of us now, incredibly beautiful. And some people find that beauty irresistible. I certainly do, but they are certainly irresistible and seductive to insects, yeah, and birds, for that's what its beauty is about in actual fact, okay? But wait a minute, there is another aspect as well. They're remarkably ingenious. They're able to manipulate animals. Now, that doesn't seem very sensible at first, but it is a truth. We're looking at a stinking iris on the screen in front of us now. We're looking at that in just a moment. They are ridiculously persistent, yeah? I mean, come on, give up, for goodness sake. They will not give up. They keep, you know what? In my garden, we decided that we couldn't possibly, now then, I'm not one for garden plants because I know many wild plants, but yeah, these foreign things that they bring in, I'm not so hot on, right? But we had a wisteria. But of course, wisteria can grow serious big. I mean, what did they put? What were we doing with a wisteria on the side of a garage wall? And it overwhelmed so we had to get rid of it in the end, all right? Years and years later, I'm talking 10, 15 years later, it still sometimes sends a little shoot out through the gravel of the drive. Amazing. And they're clinging on in this situation in the face of overwhelming odds. Talk about persistent. Oh, and they're absolutely massive. Of course, they're the largest living thing. We're looking at sequoia trees. Have you ever stood in Sequoia National Park? You know, I've been lucky to do that, as you can see. Looking up at those trees, wow, you feel small. They are enormous. Plants they can also be very, very tiny, unbelievably small. And this one little tiddler, he's not as big as my little finger, a tiny little fella. It is, in fact, an early spider orchid that we're looking at on the screen. So they can be big, they can be small. There's so much, this is plants we're talking about, so much variety. I haven't finished yet. They're in every single habitat that you could possibly come up with, yeah? Even in salt water. Yeah, of course you know this stuff. But I hope that I'm re-infusing you with stuff that you already know. Here we're looking at a collection of seaweeds. There are so many different types. We ain't going to have opportunity to think and talk about seaweeds. There's just so much we could talk about. But I will just say this. How often, you know, if I'm walking through a piece of woodland and someone says to me, what's that? What's that? And I say, oh, it's a flower. Was that what they meant? No. They meant, what kind of flower? And they say, what's that? What's that? And they expect me to say, oh, greater stitchwort, lesser stitchwort, celandine, lesser celandine, greater celandine. They want to know, is it a bluebell or is it? That's what they want to know. Seaweed, that covers everything, doesn't it? What's that? Seaweed. Job done. No, there are loads of different types of seaweed alone, right? So what does it take to create a plant? This is incredible. Almost nothing. You've got, apart from the seed, you've got the seed. What else does it take? Nothing. Just put a seed in the ground. What is it? Air. Yeah. Well, we ain't short of that, are we? Water. Well, in Scotland, and here, come to that, we ain't short of water. Yeah. This is what it takes to create a plant. Air. Duh. Yeah. Water. Plenty of that. Yeah. Light. Yeah. Well, yeah. And a handful of minerals. That's it. That's it. That's all it takes. Air, water, and light. And virtually, other than that, the whole wood or forest develops from a seed and exists entirely upon that we see. What are you looking at here? And as you're looking at this picture, you're telling me, oh yeah, I'm looking at trees, yeah? Oh yeah, I'm looking at leaves. You're saying, oh look, there's some conifer there. And oh look, there's some yeah, is that what you're looking at? I want to tell you something else. You are looking at an industrial estate. Oh. And you're saying he's gone mad, but you know what I'm talking about. For this is amazing. This is it is using a limitless free source of energy, light. Yeah, everything needs a source of energy, and it's using light. Yeah. And as we look at a leaf, let's think about this, because we all learned this at school, for goodness sake. Each leaf takes light energy, yeah, whatever that is. Yeah, I don't really understand that, to be honest with you. You might have one of these things on your roof, you know, what do they call them? Solar panels. But anyway, so it uses light energy, and it uses it to split water, yeah, into water. That's a liquid, yeah, at this stage. It now splits it into hydrogen and oxygen. This is unbelievable stuff. And so it takes water, it splits it into hydrogen and oxygen. It gets rid of the oxygen, it don't want that. And it then combines, which is jolly good because that helps me breathe, yeah. And it now combines the hydrogen with carbon dioxide from the air, yeah, to create glucose, sugar. Amazing. All forms of life rely upon this process. We call it photosynthesis. We learned about it when we were kids, and now we've known it all our lives. We're getting a bit long in the tooth now. Well, I am. You look all right, but I'm getting a bit long in the tooth now, but I haven't lost my enthusiasm for these marvels that are going on around and about us. Consider how every single leaf changes throughout the season. They start so tender, so delicate, so fresh. They're so lovely. Oh, and consider how they're arranged on each twig to make the most use of the light. Yeah, these are beech leaves that we're looking at on the screen. Yeah, remember that, beech leaves. We'll come to them in a minute. But look at that little wiggly. Yeah, I like the wiggle because it enables each leaf. Yeah, because when you're looking at a mass of leaves looking down on a mixture of woodland edge plants, they're jostling each other for space. There seems to be little order, but in fact, each leaf is arranged as best it can to get the maximum light and the minimum overlap with other leaves. And when you look at it in that situation, it's such a muddle that it doesn't seem real. But when you look at a plant called, this is black medic, it's only a tiddly little plant. It's the sort of plant that you walk on when you're going across the lawn. And you wished it wasn't there, but it's growing, and it's growing here on the edge. But because it's overlapped a path, you can clearly see now minimal overlap. Do you know what? Hardly a leaf is overlapping with another. They've arranged themselves for maximum light. Yeah, maximum light. I wonder what would happen if I'd have pushed them around and overlapped them a bit. They'd have unoverlapped themselves, if that's a word. Hey, we were looking at beech leaves, remember that? But now what's happened to them now? You see, during the season, they change dramatically. They start off so delicate and fresh. What are they like in midsummer? Well, they're dark green by then. And of course, they've become more leathery. But now, of course, we've got through to the autumn. Now, the leaves, listen, these leaves don't just die and fall off. No. Do you reckon that's the case? No. Because how many of you, for example, you've got an apple tree near the washing line, you know, and the wife's moaning about the washing is flapping against the apple tree, and so in desperation you get the saw out and you cut a branch off. Yeah, well, of course all the leaves are still attached. Yeah, they ain't going to fall off just because you've sawn it off, and you put it on the rubbish tip. Yeah. And you go back 3 weeks later, it's been really hot and sunny. You go back 3 weeks later, all the leaves are dry and shriveled up and what have you. Pick up the twig, pick up the branch, give it a shake. The leaves don't fall off, no, because they are not released. You see, these leaves are actively released. It's a definite way of getting rid of waste. And the leaves, the tree puts the waste products into the leaves. And then, of course, the leaves are actually released by special cells in the plant. The cut branch does. Hey, why doesn't a beech hedge lose its leaves during the winter? Good point, yeah? Whereas a beech tree does. Oh, same species. You see, that's to do with the amount of length of twig before the leaf. And if you cut that twig short, there's not a chance for the chemicals to build up. And so it's unable to release the leaves. Okay, then, well, here now we're looking at some of these autumn colours. In fact, I suppose we could say it's the fall because we're in Canada at the moment with this picture. The green chlorophyll is one of the first molecules to be broken down. And this is one of the reasons why trees turn red and orange and gold colors during the autumn. And once the leaves form, a protective layer of cells then grows over that exposed area. Do you know, all this is happening all day, every day, all around and about us, and we don't realize that all of these little secrets are taking place right under our noses. When the leaf falls to the ground and eventually rots, about 70% of the nutrients, I told you it took air, it took water, it took light, and a handful of nutrients. Yeah, 70% of those nutrients it took to create the leaf are returned to the soil. Putting it into language that we can understand, because 70%, here we are. It's a bit like buying a car for £20,000, driving it until it is clapped out, useless, rusted, hopeless, dump it. But you take it to the scrapyard and are given 14,000 towards a new car. That's cool, isn't it? That is what I call an efficient use of resources. Okay, plants, and this is how plants work. Amazing, amazing. Of course, some plants can't be doing with any of that old nonsense. They don't want to be involved with the photosynthesis. They probably can't spell it. And as a result, they don't have chlorophyll. And if they haven't got chlorophyll, they're not green, are they? No, these are parasitic plants. You see, they don't bother with this process, and they leach nutrients from the host plants, from the roots of the host part. This is broom rape that we see on the screen in front of us now. Dodder, this just looks like threads. Yeah, don't even bother about leaves, for goodness sake. Why should it? Don't want to catch any light, because it ain't going to bother about photosynthesis. And this is dodder that is covering gorse, and gorse is the host plant for dodder. It does host on, or does parasitize other plants as well, but very much on gorse. It grows into the vascular system of the host and draws on nutrients and moisture and whatever it needs from the host plant. It does incidentally actually produce little flowers. But we ain't talking about flowers just yet. Another way of getting nutrients is becoming carnivorous. I hadn't thought of that, because you see, there are some situations, you've got them in your area. Yeah, especially in mountainous regions. If you go to the top of the mountains, you've got to realize, of course, that it's pretty nutrient deficient up there, isn't it? Because what's happened over millennia, the rain has come down on the tops of the mountains, it dissolves the nutrients and it carries them downhill. Yeah, so over the years, all the nutrients are being dragged away downhill. So the top of the mountain is pretty nutrient deficient. So instead of bothering with chlorophyll, the sundew produces leaves with a sticky secretion that both attracts and then traps insects. The struggling insects triggers the plant to produce enzymes that dissolve the insect. Cool stuff. And the nutrients are then absorbed through the leaves. They're active killers in their own way, carnivorous, yeah? You don't know, well, yeah, we do know about it. I mean, it's not uncommon. Most people know about this kind of stuff. But I don't know, I'm hoping to reword it in a way that re-enthuses you for stuff that you've known for years. The relationship of plants and insects, it doesn't usually involve killing them, in all fairness. Not too many plants go around killing insects because plants are rooted, they cannot move. And so a huge number of plants, of course, use animals to do the carrying for them. And we call that fertilization, pollen for fertilization. Okay. And the whole relationship between flowering plants and insects is both remarkable and also incredibly complicated if you really delve into individual species and so on and so forth. They're inextricably linked, a symbiotic relationship that ensures that both species, yeah, the insect and the plant, survive. This is, of course, bindweed, right? In case you wanted to name every plant, right? Plants design their flowers specifically as a method of guiding insects into a position where they think they're getting nectar. But what they don't realize, the insect don't realize, is that he's actually getting covered in pollen. And the insect goes away feeling smug and fat and well fed. But in actual fact, the plant's going away with it even more happy because it's doing the work of pollination. Okay, then, well, flowers communicate. And you think, how can a flower communicate? Well, it does communicate, but it communicates in a visual way. We communicate talking to each other and with sound and that kind of thing, and in a variety of other ways as well. I'm waving my hands around and all the rest of it. But flowers communicate in a different way. They communicate visually with bright colors. So they're communicating to insects, to birds and that kind of thing. And they also communicate using scent. They're saying, come and get me, yeah? Come and get the nectar that I'm producing. 80% of plants, 80% of plants, yeah, use animals. In other words, insects, birds, mammals, to carry the male pollen to the female anther, yeah? These are cornflowers, incidentally, on the screen. The beauty of a flower is that purely the result of a plant's desire to attract insects. And it is also its desire to look different to every other flower, yeah? so that, you know, oh, it's me, pick me, insect, pick me. And it tries to make itself more attractive than every other flower, yeah? Does that make sense? Look, I was in Western Australia. I think of Western Australia as being just desert. Whoa, it was astonishing. As I was working there, the variety, this was all done in one afternoon, the variety of colors, intricate shapes, intricate, completely different sizes, some of them. I mean, they're all similar-ish sizes, actually, but there are some bloody great big ones as well, all within a few yards of each other. And the variety, the difference of plants and flowers is so astonishing. It really is. Well, I found it so. I didn't expect. Western Australia is actually well known for its flowers. It was just not well known to me. You know, I just thought it was like a lot of desert, and it is a lot of desert as well. Brilliant. I love it. But hang on a minute, closer to home, what have we got now? For indeed, we're looking at toadflax. Of course, when it's grown in cultivated form, we refer to it as a snapdragon, yeah? And I'm sure gardeners call it by a scientific name, yes? Because gardeners have got incredible, you know, it's nothing's what it used to be, is it? Yeah, you know, it's euphorbia. Whatever happened to wood spurge? Yeah, well, anyway, it doesn't matter. Some plants can only be pollinated by certain, in this case, heavy species. No ordinary little fly is going to get into there. Yeah, no. In fact, a bee can barely get into it. You've got to be a nice big heavy bumblebee with a bit of strength about you, because that enables it, its weight, a bit of weight and strength enables it to open the snapdragons, open the toadflax, and then, of course, now why do they do that then? Well, it forms a much more precise fertilization. The bee, effectively, because it actually closes up behind the bee and it absolutely gets blasted with, completely covered with pollen, and it now goes on to the next snapdragon or toadflax, and it does exactly the same again. And of course, the work of pollination is much more precise and uses far less pollen in actual fact. But the disadvantage is that there are far less possible hosts. What about this one? This is the opposite. You see, a big bumblebee couldn't do this one. This is this is called a tway blade, which is actually an orchid, and those are tiny little orchid flowers, yeah, because they're little, green and boring, all right, which means they're British. if you've got an orchid coming from Costa Rica, for example, I don't think I've got any pictures of that. Well, I'll talk to you about Costa Rica one day. You'll see that they got much more vibrant orchids, right? But anyway, they're very small and can only be pollinated by certain tiny little insects. Attracted by nectar, these insects set off a triggering device, a sensitive triggering mechanism that instantly produces a sticky secretion and pops the pollen onto the back of the insects. Highly efficient. And as a result, a lot of seeds. They produce a lot of seeds. Oh, this is a cool one. It's another orchid. It's a bee orchid. Yeah. Now this fella, this is really interesting. I hope you're broad-minded. Yeah, you need to be if you want to know about this one. Yeah, or put your fingers in your ears. All right. The bee orchid attracts male pollinators, by producing the sex pheromone of virgin female bees. In addition, it also provides tactile, in other words, it feels like a female bee as well, yeah, and it looks a little bit like, it wouldn't fool me, I don't think, but it falls, yeah, over amorous male bees. You can actually hide the flower from view, and the bee is still attracted by the sex pheromone, yeah. To put it bluntly, the male bee attempts to have sex with the flower. No, I'm sorry to have to tell you this. It attempts to have sex with a flower. And that is extraordinary. We won't go into it too much. I'll let you just think about it for a moment, and then that's long enough. And hey, it's not only insects that serve the flowers and do the work of pollination. Sunbirds in Africa, yeah. Oh, that's on the right. In India, on the left, feeding on flowers. And as it feeds, of course, it's pollinating each flower. These birds develop a routine, visiting one flower after another. And they go around in a circle from one to another to another. And they even defend their own flowers. That's a shining sunbird on the right, and a purple sunbird in non-breeding plumage, incidentally. It's a non-breeding male on the left. It's called a purple sunbird. Okay, Indian paintbrush. This is an interesting one. This is photographed, well, actually, I think that was photographed in Canada, if I remember rightly, but you can find it from right the way down the bottom of the Rocky Mountains, or California, maybe right down into Mexico, right the way up the coast of North America to the Rocky Mountains of Canada. Yeah, honestly. And you know what they're pollinated by? Got any idea? Look at that. Don't do it. Hummingbirds. Hummingbirds. You see, what happens is that, of course, they begin to flower quite early in the year down in the soft south, yeah. And in Mexico, California, they flower early, and the hummingbirds can begin to feed on them. But of course, they get burnt out by the heat of the sun. And of course, we move further and further and further north, and so do the hummingbirds move further and further north until they end up right the way up in Canada, still feeding upon this same species of flower, Indian paintbrush. And then, of course, they have to fly all the way back down to the bottom again. They sort of fly their migration in one go, zonk, right the way down to the south. They follow the flowering season north and migrate to the south just in front of winter. That's a white-necked Jacobin hummingbird that we see on the screen. Other specialist nectar feeders, look at this. This is a rainbow lorikeet. And of course, these can only exist in hot countries where plants, and if we're talking plants here, big plants, trees, yeah, trees. We don't see too much of that in the British Isles. Flowering trees, what do we got? We got horse chestnut, sweet chestnut, I suppose, but we haven't got too much in the way of flowering trees. But of course, you still couldn't have a bird of this type in the British Isles because it needs a constant supply of nectar. So we have to have nectar right the way throughout the year. This bird is so specialist, it can only really feed upon nectar. A little bit of soft fruit maybe if it's lucky, but its tongue is so adapted, its tongue is turned into a brush. Yeah, a bit like a paintbrush. And you know how that when you put a paintbrush into a pot of paint, yeah, the brush kind of absorbs the water into it. And that's what happens when it puts its tongue into the plant. It absorbs the nectar, and then it sort of squeezes its tongue out. Yeah, and I'm doing it. I can't talk properly. So it squeezes the nectar out of its tongue in its mouth. It is so adapted to the plant, it can feed on virtually nothing else. Now, those that suffer from hay fever know all about pollen dispersal here, don't we? Pollen grains in the air. These, of course, do not rely upon insects to do the work, and they purely rely upon air, on wind currents, on air currents, on wind, and so on. So the flowers of grasses, they don't need to be colourful. No, they're not trying to attract anything. They're trying to attract the wind. So they don't have to be colourful. Oh, they don't have to smell either. Don't have to smell nice. No, it ain't a problem because they don't need to attract anything. Of course, there are hundreds of different species of grasses. I find grasses fascinating. I enjoy grasses for some unaccountable reason. This is a cocksfoot grass that we see on the screen. Hey, but another one. What about this one? These are catkins. We all know about catkins from when we were kids. And these are the most familiar catkins, I suppose, which is the hazel tree. Or hazel bush, whatever you want to think of it. And do you know what? The thing about these ones, and a lot of people don't realize this, we've got male and female flowers on the same bush. Have you ever seen the female flowers? Some of you have, some of you haven't. I see a little nod there from somebody. Yeah. Well, what we're looking at on the screen is the male flower. That's the male. The female, yeah, they're not together. In many flowers, the male and the female are all in the same thing. But no, look here. From mid-February, female flowers appear, yeah? And these are tiny, tiny little things. They're barely the size of a pinhead. You need a magnifying glass to look at this. And of course, the pollen that comes from the male flowers, dusting in the air, making you sneeze if you're that way inclined, that then drifts on the air currents and gets trapped on the female flowers that are tiny and bud-like little things with red styles that take in the pollen. Oh, there's a good one. Bunnishberry. It's Canadian. Oh, well, I photographed it in Canada. I don't know where. I haven't seen it anywhere else. I'm sure it must grow somewhere else. It's quite prolific there. It spreads mainly by underground rhizomes. And a pollination, contrary to what you might imagine, is not reliant upon insects. Do you know what? It's got very springy petals. Unfortunately, in that photograph, we haven't got one that hasn't opened. But before they open, they're round balls. Yeah, you can imagine if you brought in those 4 petals, they form a round ball. Yeah. And what happens, that the tension builds up and builds up and builds up, and suddenly, bang, they open. Yeah, boom. And a little puff of pollen is sent into the air with that, with the power, with the spring action, I suppose we could say. Yeah. And so they actually fling the pollen in all directions, and hopefully it will land on some of the other plants nearby. That's bunchberry. And this is bunchberry as well. For now, we're at the later end of the year, back in Canada again, bright red berries of bunchberry containing the seeds, yeah, that were created by that pollination we saw about. Hey, this leads on then to seed dispersal. Listen, we're supposed to be the intelligent things because we're human beings. We flipping know it all. We can do anything and everything, yeah? But I tell you what, I bet you couldn't invent, Mr. Clever Clogs, yeah, a method to disperse seeds that hasn't already been invented by plants, right? It's astonishing. The more you go into it, the more, I mean, you could talk for the whole evening just about seed dispersal. I think it's incredible stories. You see, let's just start off with a simple one, really. If I were to ask you, you know where I'm going with this, but if you didn't know, and I were to ask you, what's going on in this picture? What's happening there? Most of you would reply that the redwing, the bird, was feeding on the berries. Yeah, redwing is stealing the berries. That's what it looks like. Yeah, and it looks as though the bird is stealing or taking advantage of the plant. What makes you think that? Yeah, I'm wanting to tell you something else. The plant is laughing up its sleeve because it's doing exactly what it's supposed to do. You see, those berries are red to attract the bird who can't resist them, the stupid thing that it is, and it comes along, it can't resist those red berries, so it eats them, it swallows them. Of course, it digests the juicy outer part, the flesh. The seed, hard seed, is there in the middle, and listen, the magic hasn't finished. It passes through the bird. All right, you might not think this is magic, but I do, because it's then popped out the other end, yeah, a mile or two away. So it's carried the seed a mile, yeah, and it's popped out there, and it lands on the ground with a convenient dollop of fertilizer. That's amazing. Yeah, well, I know you've known this stuff all your life, but just go through it in your thought. Well, later on when you've gone to bed, think about how incredible this stuff is. Plants go to great lengths to produce tasty food that the birds want. They give it a distinctive colour so that it's easy to find. Added to that, they don't colour it brightly until the seed is actually ready, so that the birds pick it at the right moment, right? You see, you can see the ones that he wants it to pick, yeah? Most of the seed is passed through. Yeah, but it doesn't want it to pick the green ones, you see, yeah? Only wants it to pick the red ones. And the bird will home in on the red ones, that's for sure. And mostly the seed, as I said, pass through, delivered a mile away with that convenient dollop of fur. Don't always work like that. It's a different one. What about this one? What do you make of this? Ooh. Well, some berries don't want to be simply put out onto the ground. Yeah, that would be useless for mistletoe. So, you see, this is incredible, really. A completely different type of berry, really. The berries are far too sticky to swallow. They can't swallow the berries. They get all gummed up in their beaks. And so, do you know what? The bird spends ages. It's nice. It likes the berries, but it spends ages wiping the berry. I'm not a very good bird, but I'm doing my best. It sort of uses its beak to wipe the berry on a branch. And in doing so, it's the sticky seed, it wipes it off onto a branch. And a new mistletoe plant is established. In this way, plants use birds to distribute their seeds. Yes. That's the truth, isn't it? Seed dispersal is absolutely remarkable. Of course, many seeds are carried by the wind or drift on the air currents. This is goat's beard. And of course, dandelion is renowned for this method of seed dispersal. You only have to think of the dandelions that keep popping up in your lawn, in your garden. And they always come up. No matter how many you take out, they'll still come up, won't they? Well, that indicates what a good method of seed dispersal. They just come in on the wind all the time. And as fast as you pull them up, they keep landing, they keep arriving. You never see them arrive, no, but they arrive and creep into the garden month after month, year after year. It keeps going, this seed method of seed dispersal. It works. Many trees use wind to disperse their seeds. Falling from a great height. Now, as kids, we must have played with sycamore. Did you do this? Or maple? And of course, the wings on the sycamore, you've got the main part of the seed in the center, and then you've got wings on either side. And what happens is it causes it to spiral and twistle in the air, yeah? And of course, that really slows the fall down. And of course, in slowing the fall down, the wind is able to catch the seed and blows it. So it's not going to blow it across the Atlantic, but it'll blow it from one garden to the next, from one piece of woodland to the next. And so there is a dispersal as a result of wind for the seeds of even the maple. There are many other. Look at this one. Aided by a bearded tit, which tears the seed head of a reed mace apart. Oh, I don't know what that animation on my screen is. Very smooth, and I expect on your screen it's jerking around all over the place. Zoom isn't very good for animation. It's very juddery and jerky for animation. So I take most of my little fancy animations out when I'm speaking on Zoom. I left that one in. The wind catches those light, fluffy seeds that we see, you could imagine, and can transport them miles. I mean, literally round the world. And you'll probably find that there are many plants that because of seed dispersal by air, they're usually airborne plants, go literally right the way around the whole of the Northern Hemisphere. And you can certainly find these reed mace in America, that's for sure. Okay, it's a very effective method. Oh, this is one that interested me. Yeah, I didn't see this. I was working on a book for a company in America, and I found some tumbleweed. Yeah, oh wow, I'm in the Wild West now. Yeah, you look for a tumbleweed being blown along with a Clint Eastwood tripping over it or whatever, or kicking it out of the way. Tumbleweed. Interesting one again. You see, this is again, it is like this to disperse its seeds. Once the sort of growing cycle of the plant is over and it's gone to seed, the seeds are retained in little pods. And you can't see them because we're not up close enough. I should have taken a closer one for you, or at least put it on the screen. But as the plant dies, those seeds are retained in little pods. The plant dies and the main stem of the plant becomes weak. For there's only one, in that ball, there's only one stem into the ground, all right? And that stem becomes weak and it breaks deliberately. It ain't an accident. It's not just because a cow has given it a kick or a wagon train has gone over it. No, it breaks deliberately, leaving this unattached ball of twigs, yeah? And the ball, of course, is blown by the wind across the prairie because it's so flat. And as the ball of twigs is blown across the prairie, it's bouncing along, shedding seeds as it tumbles along. It's like a pepper pot. Unbelievable. And so you could get a whole line of tumbleweed growing up a few years later or a year later. Yeah, amazing stuff. This is in my own garden. This is cranesbill. It's tiny, right? This is a weed in my garden. And but the power with which the seed pod springs apart, and you can see the one the darker, stronger looking one, sort of at the top, and the seeds. You can see the seeds arranged around the bottom, all right, around the base. But then the other one has already sprung. So what happens? It builds as it dries out. It builds up, the tension builds up and builds up until boing, and it explodes apart, shooting the seeds, 2 or 3 meters, far further than any little tiny plant could ever throw anything, you would imagine. It's flung like a slingshot. Oh, but what about this one? This is the seed head of a burdock. It attaches its seeds to your socks. I mean, that's unreasonable. Yeah, I mean, it's the one that when you get back to your car, you've got all these bits stuck on your socks and you're going, oh bother, oh golly, oh gosh, and words to that effect. And you're chucking all these bits into the ditch. Yeah. Well, look at the seeds. Every seed has got a long, delicate horn attached to it. And at the end of the horn is a perfect hook. A perfect little crochet hook. Folks, I can tell you that those hooks are designed for Springer Spaniel's ears, foxes' tails, and your woolly socks. And when you're getting all cross and irritable with it, throwing it into the ditch and all that, nature is laughing up its sleeve because you're doing exactly what you're supposed to do. Isn't that incredible stuff? Yeah. I've got no idea why I've included these large cones, but I like the picture. So there you go. Perhaps it's a good illustration of simply enjoying plants for their beauty. I don't know why it's there. I can't remember. I need this one. I've got to show you this one. Do you know why? Because when I was a kid, I used to ponder on this kind of stuff when I was a nipper. Goodness knows why I wasn't normal. But I knew about seed dispersal, and I thought, how does an acorn get dispersed? And I couldn't imagine it. I thought, because I was brought up in the suburbs of London, I thought, well, maybe it bounces along the gutter or something, or rolls along the gutter. I couldn't think out why, how, it never made sense. Before we move on, by the way, I will just point out, you see the water droplets on there? Well, of course, they're not actually water droplets, because I was taking that photograph and I thought, it looks a bit dud. It looks a bit, how can I sort of lift it a little bit? And in my car, I carry a spray plant sprayer. You know what I'm talking about, yeah? And so I thought, I'd give it a little spray. That was the plan. Opened the boot, sprayer gone. Yeah? So I said, oh, crikey, I say to my wife, sprayer's blooming gone. I was going to do it. I couldn't, I don't know where I've left it home or something like that. Oh, don't worry, she says, taking a swig of water. She goes, and you're looking at it now. Anyway, there you go. That's the truth. Seed dispersion we're supposed to be talking about, aren't we? How does they have it? Well, you know, because you're grown up and sensible and know a lot more than I ever did. It is the jay that dispersing them. Yeah. Yeah. The thing is, not squirrels. No, squirrels kill them. Squirrels bite the growing point and prevent them growing. The jay can't do that. The jay doesn't do that. It picks a seed off of the tree, and having picked it off the tree, it might fly 300-400 yards. Yeah, it now finds a suitable place that takes its fancy, and it flies carrying it down to the ground. Listen, it now digs a little hole. Yeah, it puts the acorn to one side. It digs a little hole. It dibbles a little hole, and it pulls the vegetation out, and it moves everything. It digs this little hole. It now picks up the acorn. It puts it in the hole. Yeah. And it now covers the acorn. It plants the bloody thing. This is unreal. This is incredible. It's incredible. Now look, it thinks it's going to find them all again. And by and large, it does. It finds a lot, but it doesn't find them all. And the rest have been planted. Not just dispersed, but dispersed and planted. That's remarkable. Of course, some seeds are massive, but others are little more than specks of dust. But these here are transported by water. Wow, it's difficult to dream up a method of seed dispersal that has not already been invented by plants. Okay, these are transported by water across oceans even, and certainly along, because when you think about a lot of these trees, palm trees are bending, overhanging the water, aren't they? They'll be transported downriver, transported by the sea. Yeah. At home, marsh marigolds, you've got more up there your way. Marsh marigold seeds are dispersed by water as well. There's various other methods of reproduction. We can't go into all this stuff, as you can imagine. There's asexual budding, which takes place with what we've just seen on the screen in front of us now. And that, of course, is duckweed. Very occasionally, though, duckweed does produce microscopic flowers that develops into seeds that are transported in the water as they float. All sorts of methods of reproducing themselves. You know, mammals have basically only got one method of reproducing themselves, yeah? But there's so many different methods of reproducing themselves. What about bulbs? Yeah, they divide, subdivide, creating clones of themselves. Mind you, bluebells also set seed pretty readily as well. That causes a problem. I wish they didn't really, because of course that causes the danger of cross-pollinating with imported variety, imported cultivated varieties. And well, I don't want to talk about negative things that really, but that's a sad one. We will eventually, not in our lifetime, he says, scan in the audience, but we will eventually, I'm afraid, lose the bluebell woods. Okay, many costs, those were bulbs there, but many plants send out runners called stolons. They're horizontal stems over the surface. And these start a new plant. We know about them with strawberries, don't we? Wild strawberries at home. This is goat's foot, this particular plant on the screen in front of us now. Other plants produce rhizomes. Yeah, stolons are long runners that go across the surface of the water. Rhizomes, as you know, are under the not surface of the water, surface of the ground, right? And rhizomes actually go under the ground like roots, basically. And they can go great distances to establish new plants. And this is a classic marram grass. It has loads of other adaptations to enable it to thrive in this difficult environment, but it's so effective that it stabilizes the sand dunes so incredibly well that it will cause its own downfall. Yeah, it kills itself in the end because it does such a good job of stabilizing the sand that plants begin to come into their own, things like bushes even, sort of like sea buckthorn, for example, and that kind of thing begin to take over, and the marram grass is overwhelmed and swamped, and that's the end of it. Has to keep moving to survive, keep moving. Hey, whilst marram grass establishes new land in the colder climates, in the tropics, yeah, mangroves, amazing trees, they do a similar work. roots create an interlocking network that can withstand the tide, even stormy seas even. Quite amazing. And they do the work of marram grass in the tropics, or marram grass does the work of the mangroves in our temperate sort of climates, yeah? Everything in nature fits in remarkably well together. Oh, grasses are the most adaptable plants. Many animals feed exclusively upon them. But the grass needs the animals to do the work of grazing. You see, there's a tendency to think that it's necessary. We've got to have the animals grazing the grass, because if we don't have animals grazing the grass, we get competing vegetation taking over that very quickly overwhelms the grass. Because here, as we're looking at the bison in this particular situation, it ain't just grazing the grass, it's grazing everything else that its tongue wraps around, including seedlings of trees, including what we might regard of as weed species. I don't know that you know what I'm talking about, but it grazes on everything, right? But grass can survive. You see, most plants that are grazed can't survive. If you bite off a tiny seedling of a tree, once the top's gone, that's the end of it, yeah? But that doesn't matter, you see, that's not a problem. That's why grass is so special, because the growing point of grass is at soil level or even below it. And so the growing point never gets got rid of, yeah? If the prairies are not grazed, they would quickly become a forest. What about this one? Masai Giraffe. He's able to use his tongue in between the acacia thorns. Yeah, it's extraordinary, because by Jiminy, I'm telling you, those thorns are sharp. I know that to my detriment. However, although he's now learned to get in amongst the acacia thorns, the acacia tree's got another trick up his sleeve. He provides a home for ants. Can you see those dark dollops on? I don't know whether you can see them on your screen. I can see them on mine. Hey, what about the one actually under? No, oh yeah. Can I get my cursor up there? I don't know if I can. No, I can't put the cursor up. The one right under his throat, the outer focus bit, under his chin, yeah, or under his throat. And you can see all the brown dollops, yeah? All those brown dollops are ants' nests, yeah? The acacia tree actually provides homes for ants. And what happens is, when they feel the vibration of a giraffe having a nibble, yeah, they now defend the tree. Yeah, this is remarkable stuff. And how can an ant defend against a ruddy great thing like that? They squirt formic acid. Oh, and in the end, it gives up because it begins to taste really horrible. Yeah. Incidentally, the other thing is, and again, nature is amazing. The acacia tree only produces thorns around the edge of the tree. Yeah. Don't produce them in the middle, because animals can't get at the middle. Because they've got to start from the outside and make their way in. And they can't do that. There's so many miracles going on here. Oh, this is interesting one I photographed in India. Mimosa leaves. Oh, they look delicate and delicious, don't they? They're not actually poisonous, but they can defend themselves. How can a plant defend itself? You know, you're kidding. No, what happens is there's a slightest vibration and they fold up. Could you see how they're folded up into a narrow, yeah, incredible. And they fold up. And quite often, a caterpillar, for example, it almost falls off it as the plant just folds itself together. And other animals don't seem to want to know it once it's folded up. But there we go. That's mimosa. Oh, this is interesting. But now we're at the top. In fact, although we call them alpine plants, don't we? But we're actually at the top, not of the Alps in this situation. We've got some at the top of the Alps somewhere, but these are growing at the top of the Rockies, and yet we still call them alpine plants. Rockine plants doesn't sound quite right, does it? Well, anyway, alpine. But you can see how hairy this is, yeah? This is an Alpine Forget-Me-Not. Oh, come, yeah, you can kind of see the family relationship, can't you? But it is very, very hairy, yeah? And it is well known as very low growing, and with his wearing a fur coat because it's hairy, and so air gets trapped in there, And it is true that it is actually, if you could test it, which they do, obviously, these scientific people that do that kind of stuff, test the temperature inside there, it is often 1 or 2 degrees warmer. How it gets warmer, I haven't worked that out, but it actually is warmer in there, in the heart of the plant, than it is in the surrounding environment. But what about this one? This is the most northerly plant that I've ever photographed. This is on Spitsbergen, 580 miles from the North Pole. It's the most northerly plant I've seen anyway. And what, again, we've got this same thing, huddled up tight to conserve warmth. Within the center of the ball, could be a degree or 2 warmer. Plants are incredible. Absolutely amazing. There's so much more we could talk about. I'm looking at the clock, but there is so much more we could talk about. I've not even mentioned fungi. What? Oh, crikey. Well, you want another evening? Yeah, we could just go round again, couldn't we? Talking about fungi. Thousands of different fungi. I mean, we got enough in the British Isles. If you start going to other countries, it's mind-blowing. It really is. There's so much to plants. Plants, wow, they're varied beyond belief. The weirdest, we just lump them all together and say they're plants, but they're varied beyond belief. We lump them together, but they have incredible detail. Wonderful illustrations of packaging, yeah, and the vulnerability that happens to be horse chestnut that we're looking at on the screen now. I'm not sure how well these animations would work for you. I'm hoping that they look something. They look good when you've got a big screen in the front of a hall. I'd quite like to get up to you in May, yeah, next year. If I do, I'll give DJ a ring and see if we can meet for you yourself. I don't know. We'll see. I don't know whether I can. I've got to find somewhere to stay. Right. But incredible detail we were talking about. Oh, earlier on we talked about seaweeds, didn't we? They live in impossible circumstances. Oh, salt water, back and forth. Half the time they're in the water, half the time they're out of the water. When they're out of the water, the sun's beating down and they're getting cooked. Now suddenly they get whacked again with freezing, flipping cold water. Yeah. Impossible circumstances. That bladder wrack that we see on the screen, of course, in front of us now. But they are amazingly resilient. And they can cope with the most ridiculous scenarios. Frozen to death. Yeah. No, not to death. Just to go into a form of suspended animation. And they're beautiful in their intricacy. Perfect examples of packaging. As here we're looking at a fern frond. Yeah. I tell you something else. They're well able to defend themselves. Look at that. Yeah, they are. And again, I could tell you a story. I will tell it to you quickly. I was working in America and I was photographing in a cholla cactus garden. It's not actually a garden, it's just a massive cholla cactus. And when you get a massive cholla cactus, they call them a garden for some reason or other, because they're horrible. Well, they didn't used to be, but I discovered that they're horrible. Yeah. The thing is, when you're photographing, I'm 6'3", so I'm quite tall. So the tendency is to photograph everything from 6'3" high. Well, no, it's not really, because I'm a keen, obviously I'm a professional photographer. And so you go down. Now, the very process of you going down, you'll discover, is a cantilever effect where your head goes down and your bottom comes out. Do you understand where I'm at? Am I explaining this well enough for you? I might have a delicate and small bottom, but my bottom comes out, yes? And I'm telling you, cholla cactus jump. I swear they jump. Whack! No. Oh, I back right into a flipping cholla cactus. My backside, unbelievable. They're so sharp. It's unbelievable painful. And I'm sorry to have to tell you, but this is a true story. My wife was beside herself with laughter. This is the honest truth. She was beside herself with laughter that she couldn't pull them out for me. And a strange woman had to pull out these cactus for me. Yeah, how about that? Hello, young lady. Got a little young lady joined us. Just joined us in time for the end. what a shame. Look at those spikes. Plants are well able to defend themselves. Yeah, they are tough beyond belief. Plants are incredible. And I hope that you've discovered my view on plants. Thank you very much. Okay then, well, that was a pretty precise time. And he says, looking at his clock, exactly an hour. So we can come off of, I'm going to come off of screen share a moment. So we'll just go back to there. And then you can take yourself off of Zoom. And I can now hear you now, if you're off of mute. Okay, and if you any questions,
Daddy.
Right, are there any questions from anybody? If you want to wave your hand or shout, then I'll know. No?
Rhododendrons used to grow wild in Lewis.
Oh, rhododendrons.
But they cut them all down.
Yeah, I didn't. A good job, really.
Yeah.
I'm not. I mean, the thing is, again, this is a human ability, isn't it? To think that we know better and think that we know what's the right thing to do. I didn't include rhododendrons. I mean, they're obviously Asian plants, which are not supposed to be in the British Isles. And the problem with them being in the British Isles is that they are very, very powerful plants that overwhelm everything else. I'm sure you people know all this stuff. You probably spent hours chopping them down yourselves, and they overwhelm everything else. Nothing can live underneath them, and nothing, you know, wants them. Nothing feeds upon them, so they contribute nothing to the environment, and yet they rob the environment of things that should be there. So that's the reason that, yeah, I'm not very fond of them. We have a similar sort of problem actually on the Purbex in Dorset. So so it's a problem. Places like our nature reserve. Okay then.
Oh, well, thank you. If there's no more questions,
Pleasure.
it remains for me to thank David